Moving on through chapter 7, we're going to be talking about glycolysis in lecture 2. Glycolysis literally means sugar splitting. And that splitting is going to become important as we go through. All right, so glycolysis is one of the oldest biochemical pathways that we know about in living things. It is common to all cells, even prokaryotes, okay? And then all eukaryotes are going to do glycolysis. It takes place in the cytoplasm. And it is a pathway of 10 reactions. Now again, I'm not going to ask you to memorize all 10 reactions or memorize a bunch of enzyme names or intermediate names or any of that. You can do all that if you take biochemistry. I am most interested in what goes into the pathway and what comes out of the pathway, not just at the very end, but those important energy harvesting steps along the way, okay? We can subdivide glycolysis into 2 phases. The first phase is the first 5 reactions, and it is called the energy investment phase. Okay, so glucose is the starting substrate for glycolysis, and glucose, you know, is a sugar. It has a lot of energy stored in its chemical bonds. But remember, every reaction, every chemical reaction has activation energy. And in the first 5 reactions of glycolysis, we actually use up 2 ATPs. Well, I told you in the last video that the end goal of aerobic respiration is getting energy out of glucose and other food molecules to make ATP. So why are we using ATP to start with? We've got to prime the reactions and get them going. We've got to input some energy, and you're going to see that a little bit more later. The next phase of glycolysis is the energy payoff phase, and that's reactions 6 through 10. Now notice that in reactions 6 through 10, we make some ATPs, we make some NADHs. Now remember, what's NADH? NADHs are those electron transport molecules that we talked about in lecture 1. NADH has been reduced, meaning it has picked up electrons, and now it's going to carry those electrons to the electron transport chain in the mitochondria. And remember, electrons are synonymous with energy. Okay? And then the final product of glycolysis is called pyruvate. Pyruvate is what goes on into the next stage of aerobic respiration that happens in the mitochondria. Okay, so overall, in glycolysis, glucose is oxidized, meaning it's losing electrons, it's losing energy into pyruvate. And then the energy that glucose lost was being put into making ATP and also making NADH. Okay? All right, so in this slide, we're seeing the first 5 reactions of glycolysis. And again, don't freak out about all the enzyme names and all the chemical structures. You don't have to memorize that. What I want you to see, though, is that in reaction 1 ATP is used up and we phosphorylate that glucose. And then in reaction 3, another ATP is used up. Okay, that's where this energy investment comes from, using up 2 ATPs. And then remember I told you earlier that glycolysis literally means sugar splitting. Well, in reaction 4, this sugar molecule that has now been converted from glucose into fructose 1,6-bisphosphate. Again, you don't have to worry about those names. We started off with a 1,6-carbon sugar molecule. Reaction 4 is going to split this sugar molecule right down the middle. And so now we have 2 3-carbon molecules. But after reaction 4, they're chemically different from each other. Reaction 5 is going to convert them so that they are identical. Okay, so what have we done in the energy investment phase of glycolysis? We've used 2 ATPs and we have broken our 6-carbon molecule into 2 identical 3-carbon molecules. Now, if we look at this from an energy progress curve perspective, we're starting with glucose, okay? Glucose is already a energy containing molecule, right? But we invest energy from 2 ATPs and we move up even higher on this energy progress curve, okay? The next 5 reactions, the energy payoff phase, is where we're going to start our downhill journey, okay? So let's look at that next. In our energy payoff phase, remember, we're starting off with 2 identical 3-carbon molecules. Each of these 3-carbon molecules goes through reactions 6 through 10 by themselves, okay? So when reaction 6 says we get 2 NADHs, we get 1 NADH per 3-carbon molecule for a net of 2, okay? So in this very first reaction in the energy payoff phase, we've got an oxidation reduction reaction. We've got a redox reaction going on here. Our 3-carbon molecule is oxidized. I'm just going to write oil here for shorthand. And our NADH is reduced. Sorry, our NAD plus is reduced to NADH. In reaction 7, we actually get ATP. And then we've got some more interesting biochemistry going on. And then in reaction 10, we actually get some more ATP. And then our final product of glycolysis is pyruvate. Now notice in this figure we've got, it looks like there are 2 pieces of paper stacked on top of each other. That's just to remind you that each of these reactions happens twice because we've got 2 3-carbon molecules that are moving their way through these 5 reactions. Okay, so if we go back to our energy progress curve, we had started here with glucose. We had gone up in energy because we invested ATP. And now we're going to start coming back down, okay? We're going to get some energy out in the form of NADH. We're going to get some energy out in the form of ATP. Oops, sorry. But remember, per glucose molecule, there's enough energy to make between 30 and 32 ATPs. We used up 2. We made 4 ATPs, but 2 of them were just paying back our energy debt. So we only have created a net of 2 ATPs right now. Well, glucose is supposed to give us 30 to 32 ATPs. We're not finished, okay? At the end of glycolysis, we have 2 molecules of pyruvate. Most of the energy that glucose started off with over here as our initial substrate, most of that energy is still stored in pyruvate. Okay, look at all of this distance right here. We've got a lot of energy harvesting to do that didn't happen in glycolysis. That's what the rest of aerobic respiration is for, okay? Now, I want to talk just briefly about the reactions that formed ATP, because when we talk about aerobic respiration, and then in chapter 8, we're going to talk about photosynthesis, there are three different reaction mechanisms that ATP can be formed. The first one we're introduced to in glycolysis, and it is called substrate level phosphorylation. You see the word substrate, what do you immediately think of? You should immediately think of enzyme, okay? So for substrate level phosphorylation, we're going to have an enzyme, and you guys know I'm a terrible artist, okay? And so we're going to have one of the things that's going to bind this enzyme is the substrate that has a phosphate group on it. Okay, that phosphate group came from the energy payoff phase when ATP was used up. Well, ADP is also going to bind to this enzyme. Substrate level phosphorylation, what this is telling us is that this enzyme is going to catalyze the reactions that break that bond holding the phosphate group on to the substrate, and the energy that comes out of that, of breaking that bond, is going to be used to add that phosphate group to ADP. That is going to create ATP. Okay, so if we look at it this way, we've got our substrate with our phosphate group. That substrate is going to lose the phosphate. The phosphate's going to come out, okay? There's also going to be energy that comes out. The enzyme is going to use that energy to phosphorylate ADP to make ATP. Okay, so again, we're coupling here, right? We're coupling this exergonic reaction where we're stripping that phosphate group off of the substrate to the phosphorylation of ADP. Phosphorylation just means adding a phosphate group, okay? So we are phosphorylating ADP in order to make ATP. But remember, creating ATP is highly endergonic. Got to put a lot of energy in. That energy comes from breaking that bond that's holding that phosphate group onto the substrate. Okay, so this is substrate level phosphorylation, using an enzyme to transfer a phosphate group from an initial substrate onto ADP to make ATP. Okay, I don't think I need that slide. Okay, so summary, energy investment phase, we're starting with glucose. We use up 2 ATPs. So now we have 2 ATP debt. Energy payoff phase, we form 4 ATPs. 2 of them are going to be used to pay back the debt. We form 2 NADHs, and 2 pyruvates. Okay, so our net products of glycolysis are 2 pyruvates, 2 ATPs, and 2 NADHs. All right, so most of the energy of glucose is still stored in this pyruvate. ATP can go be used in other cellular work. NADH is going to go to the mitochondria to the electron transport chain. And we'll get to the electron transport chain in later videos. Okay, so what do you need to know about glycolysis? What goes in? Glucose, ATP. What comes out? ATP, pyruvate, NADH. Okay, that's the in a nutshell what happens in glycolysis. Okay, and remember, these reactions, these 10 reactions, are common to all cells. They happen in the cytoplasm of all cells, whether or not those cells are eukaryotic or prokaryotic.